Hello everyone, it's April 22nd. I did some AWS today, which well, I know how the Lambda function works, but I haven't touched it for a while, so I forgot that it has a feature called restart if it fails. Now I wrote a Lambda function which I wanted to fail. I shouldn't say I wanted to fail. It will fail because whether it fails or not doesn't matter. I just want to use the Lambda function, send an API call, and I don't care about the return. But I forgot about the retry thing, so I just set it up and I used CloudWatch to trigger it periodically, and then the result just looks so weird. The Lambda function gets triggered much more often. Like I want to trigger every 15 minutes, but it got triggered every like 2 minutes. It's like, what the hell happened there? Took a lot of debugging, and then just by accident I took a look. It's like, every 2 minutes. It feels like there's some redo out there. And took a closer look at the configuration of Lambda. Well, it is. It has a retry set to 2. I mean, I could just set back to 0, it's like no retry, which can solve all my problem. But yeah, I thought about it. Why fail it, right? Why fail it? I can just set a timeout in the API call and then just end it nicely, gracefully. But that one took a while for me to debug. Anyway, all right, let's get into it. We don't have anything to see here. Brick wall. All right, what's brick wall? Oh my god, this one looks cool. They have a watermark. All right, take a look. There is a brick wall in front of you. So that's a wall. The wall is rectangular and has several rows of bricks. The bricks have the same height, okay, but different lengths. You want to draw a vertical line from the top to the bottom and across the least bricks. The brick wall is represented by a list of rows. Yes, each row is a list of integers representing the width. Okay. If your line goes through the edge of the brick, then the brick is not considered as crossed. You need to find out how to draw the line to cross the least bricks and return the number of crossed bricks. You cannot draw a line just along one of the 2 vertical edges, in which case the line will obviously cross no bricks. The width of the bricks in different rows are the same and won't exceed 8 max. The width sum, the number of bricks in each row is ranging 1 to 10,000. The height is ranging 1 to 10,000. Total number of bricks won't exceed 20,000. Oof. All right, let's take a look. So we're gonna draw. I mean, one way to think, we just draw, but that's definitely not gonna work. That's gonna be 10,000 times 10,000 checks, which will give us. Actually, it didn't say how many rows. It said the number of bricks in each row is in this, and the height of a wall is yeah, so it's 10,000. So it's going 10,000 by 10,000. The naive way is 10,000 by 10,000. We're definitely not going to do that. So, we're going to draw a line, right? I mean, ideally, we should definitely find gaps, right? So we can use gaps as our starting point. I mean, we should always go, if we have a gap, we should always go with a gap. So at each level, we should assume, I mean, yeah, there are definitely going to be gaps, right? It's not possible to have the minimum block. I mean, if we don't have any gaps, then the minimum number is just the total, right? So if we have a gap, we're always going to try. So on the first level, doesn't matter which, we're going to go top down, doesn't matter. So top down, we have gaps. So we assume that we will cross this gap. And then we find out the minimum number of bricks that can be achieved by going through this gap. So if we go through this gap, and we get a certain amount, and going through this gap, we get a certain amount, going through this gap, right? And then on the second level, we have gaps as well. So we check the gaps, check the gaps. So each level, we're going to check the gaps. And eventually, so yeah, this is a DP solution with memorization because we check the gap, right? And then we say we're going to check this one, and then we go here. So the first level, we say, hold on, first level is here, so we have a gap, and then we need to find out, actually we don't need to find out, we know this one is this, and this one is this, right? So first level, we have a gap, and go all the way down, right? And then we say, oh, this is another level. Hold on, how do we phrase this? We basically gonna draw a line from this gap down, and as we draw it down, we already know this one, right? So we go down, and then this is no gap, so and then this is a gap. Then we're gonna call it again. So we're gonna find the maximum that can get here, and then when we reach this level, and we don't have to check again. We just see the gap we already have, so we know how many. But why do we still need to do this? I mean, we don't have to. Well, we do have to, because it's possible. Like here, the gap is here, so it has to be the gap and across the entire thing, right? So we find the gap. We have to go through the entire thing. How do you do DP with it? I mean, we have this gap going down, right? And if we meet another gap, then this one we already find out. And we meet this gap, and this one is already find out. So when we go here, we don't have to do this again. When we go here, we don't have to do this again. Here already we have these three gaps. They're aligned. So aligned gaps we don't have to do again. All right, so we do this, 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 done. Next level, this one we already done. This one we have not done, so we need to go down, and we need to go up, right? So when we're done, everyone on this gap is good. And now we go here, we've done it already, We have to do this, right? And then we have to do this. This one's done, this is done, this is done. This one is done already. So we have to go through every row, right? Because each row wait, they have our Tupperware, right? Yeah. All right, so we have to go through each row, and that's ON, right? To call OM, and within each we have to do the number of gaps. Oh, the height of the wall is in a range, and the number of bricks in each row is in a range. So that's still these two multiplied together. We still have to go through everything, right? We go through this gap, right? On this gap, we go through everything, and how do you define gap? I mean, gap is just in between, right? In between, and hold on. So we definitely go through gaps, right? Unless there's no gap. So like in the first row, we have 3 gaps, and 2 gaps, 2 gaps. So we have to go 3, and as we go, we know the gap has been from the gap going down. Is that correct? Yeah, I think that's correct, but the runtime seems still to be high. And we just go gap to gap, right? That's ON. And then we check every one, and then for each one of them, we have to check every single, we have to check the entire column, right? Like for this gap, we have to check this, and check each row, right? We check everything. For this gap, we have to check everything. For this gap, we check everything. And because it says the number of bricks in each row can be, so I can have like 10,000 bricks, and I have to check 10,000 rows, and that's already 10,000 times 10,000. We haven't even reached the second row yet. How is that? That doesn't seem to be right, right? I mean, all we need to do is to get the minimum number of bricks we have to cross, right? Minimum number of bricks we need to cross. Let's see if we can find something a little bit smarter than what we have been thinking about. I don't think this one's working anymore. I'm gonna get a new piece of paper. Okay, new piece of small paper. I don't like big paper. All right, small paper. So what we need to find out is the minimum. So I have 1, right? If we do prefix sum, I don't know, just trying things out. 3, 4, 5, right? And then 1, 4, 6, and then 2, 6, and then 3, 4, 6, and then 1, 4, 5, 6. Okay, so if we do prefix sum, we can align them, right? So we say it's 1, 3, 5, 6. That's first row. Next one's 3, 4, 5, and then 1, 4, 6, 2, 6, 3, 4, 6, 1, 4, 5, 6. That's just we adding them together, right? So 1, 3. That's telling me where the gaps are, right? So the gaps is going to be at position 1. Well, like here. Next gap is position 3. Next gap is position 5. The final gap is 6, and we don't really care about the 6. How come the row number 2 is 3, 4, 6, not 5? God, 3, 4, 6. So we end up at 6, all of them, right? Which means we need to find out a gap, which means is the sum is the same. Right? So, for example, the 4, right? Number 4, we have 4 here, 4 here, 4 here, 4 here. So we have 4 appearing on 4 occasions. I think this is like, if we want to do this gap, we have 3. 1, 2, 3. If we want to do 2, which is this gap, we have to cross all of them, right? So we'll have 1 that we do not need to cross. If it's 3, there's 3 we do not need to cross. 4 is we have 4 do not need to cross. 5 is 2, and 6. Yes, that is the solution. We are going to do a cumulative sum, prefix sum on all of them, and once we do that, we're going to count. We're going to count the number of values. So we do each row, and we do a count. And we can return the one with the largest count. I mean, the largest count minus the total number of rows. Okay, cumulative sum is ON, so that's going to be ON for each row. And then we put that into, we can do that as we go through. Yes, we can put that, so it's going to be on. That's still going to be on squared. That's still going to be on squared. But it's, I mean, let's try. I'm not sure 100%, but that seems to be working. All right, maybe I should like, yeah, I'll do it. I mean, it's, by describing, it's not really making any sense. But once you see, right, once you see how it looks like the prefix sum, then you will have an understanding. All right, let me do this. So prefix sum for first row, 1. Let's intentionally put this, so 3. Let's do it this way. 1, nothing. Let's put this, 3, and nothing, 5, 6. That's first row, right? Let's just put an empty space. That'll be easier to handle. Second one, we have 3, and then 4, right? And then 6. Next one, we have 1, 4, 6. Next one, 2, and 6. Next one is 3, 4, 6. And the last one is 1, 4, 5, 6. So we can see these are the aligned where the gaps are. So if one of the first gap, we have 3 gaps. Second one has 1 gap. Third one has 3 gaps, 4 gaps, 5 gaps, and all the gaps. Now we cannot use this. And so what we need to do is find the smallest, no, find the largest count of this. And the answer is the total number of rows minus this, right? So it's fairly straightforward. I think it only needs a few lines, like really a few lines, and then we can solve this problem. All right, so this is what we're gonna do. We need a counter just to make things easier. So we're gonna say gap count, right? Gap count equals counter. And then we're gonna say for row in wall, cumulative sum. How do we do cumulative sum? We're gonna do pre-sum. That's called prefix sum equals 0. And we're gonna say for brick, called BR in row, right? For brick in BR, pre-sum plus equal to this, and gap count. Actually, I don't need to do gap count. Oh, yeah, that's fine, I think. So it's pre-sum plus equal 1, right? And then we're gonna say we are going to find the maximum among this. Well, can you call max? Well, we're actually gonna not do the last one, right? Do we do the last one? No, we don't need to do the last one. So we can actually do. Yeah, that's fine. Yeah, I guess it's fine, right? I mean, there will be one value that's the largest. I don't want to sort it. I just want to find the second largest. I want to find the second largest within them. And we need to know, yeah, I think we do. Yeah, we do. So we also need to know the max row, no, max width, right? Width, I'll call it width. Width equals 0. We don't know width, but after each time we can set width equals pre-sum. Right? So that's the end, that's the width. And then we're gonna set We're gonna set gap count width because we want to eliminate it. And then we're gonna return max gap count dot values. And we do len wall minus this. This is the number we need to cross. Okay. So yeah, I'm not gonna test here because it's fairly difficult to write a test case. So we just try it. See, what's that? Built-in is not iterable. The values. Two. Okay, let's try it. Hopefully it doesn't time out. Yep, we got it. So straightforward, pretty straightforward. Yeah. So by turning each row into a prefix sum, we can easily see where the gaps are on each row. For instance, given a wall like this, that's just, it's good, man. We always need to give some examples, right? This is the realign. This is the align prefix sum of each row. Clearly, we can see that with 4, we have the most number of gaps, which in turn means that with 4, we cross the least number of bricks. Therefore, the solution is to compute the prefix sum for each row and count and keep counting the frequency of each width. The final result is the height of the wall minus the max number of gaps at a certain width. Right, and then we see here, do not include the do not include the max width as Yep. And what do we have for this one? Brick wall. Yeah, that's about right. It is on squared. Actually, it's not on squared. It's ONM, where n is the number, the maximum. Yeah, maximum number. Yeah, it's the, I'd say the average number of bricks per row, and m is the number of rows. We get 180 milliseconds, which give us 72% ranking. Yeah, I think this is probably the official solution, most likely. Is it possible to make this even better? I doubt it. I mean, this one looks pretty good. Right, it looks pretty good. Yeah, I think this is good. Brick wall. All right, let's see if this one has a solution. Nope. I think this is a medium one. It's a pretty straightforward medium question. I mean, you can't even say it's a hard one. Nah, it's a medium one. It's not a hard one. I mean, if you go down the wrong path, like when I first started, it could cause serious trouble. Right? You're trying to say, okay, is it possible for us just to check every single one, and you can, it's going to cost a long time. It's going to cost ONM for each check. for each row. So that's why it's definitely not gonna work. 554. I don't think I've done this before. Nope. Take a look with pictures. Oh, I like pictures. That's just the same picture. 4. Okay. 6. Next edge position. Yeah, it's the same idea. Cumulative sum. I like to call it cumulative sum instead of prefix sum, but we know frequency. Yeah, 4 has the most frequency. 5. Yeah, 5 is 2. Oh man, that is edge case. Oh, I didn't even consider edge case. Holy moly. Oh yeah, I don't have to consider edge case because for edge case, when we turn out everything to 0, right? The edge case is when you do the max the value to 0. So it's the I didn't even consider the edge case. What is this? Can't cross the walls with purple lines. Oh no, that's the previous one. Edge case 2. That's not an edge case. It's fine, right? It's fine. Yep. Good visual. I'll give it upvote on this. Good visual. Easy solution with counter. Else. How? Yeah, -1. Yeah, that's fine. Yep. All right, that's it. It's a good one. We solved it. Fairly straightforward. All right, I'll see you guys tomorrow. Adios.